All right, so we're back in the room, and so we're in comfort zone back again. And I had to come out because we were getting some technical difficulties, and I wanted to share. If you look at the topic this morning, uh, short circuit troubleshooting. We're gonna go through that, right? We're gonna go through short circuit troubleshooting and the the way how to troubleshoot, and I have 10 steps I want to share with you this morning, right? 10 steps on 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 short circuit troubleshooting. Okay, there is 10 steps, and I want to share with you the 10 steps this morning, right? And so I was before we get started, right? You have your goggles, right? You working in the field. You have your earplug if you're gonna be running a machine or a generator or whatever equipment, right? And there will be noise. Um, Protect your ears from extreme noise, and it's very important, right? And some people would use the two system you use in your earplugs, right? And also the muff. And it's very important that you protect your ears from extreme noise and loud noise. Okay. So as I said, last week we spoke about I spoke to you pertaining to different types of fluke measuring instruments, right? Those multi-testers, and how you would purchase one of them based on your application, based on what you're using them for, what you're going to be using the multi-tester for, right? There are different models that you can use. Instead, you might just doing basic testing. You don't want an expensive multi-tester, or you doing a lot of troubleshooting motors, electronic circuitries, and those and so forth. And so I was mentioning that the best multi-tester for field technicians, because we're doing so many things, troubleshooting different equipment and so forth, is the Fluke 87V, right? The Fluke 87V. And so that is what we were discussing last week. And you're in the tech corner today, and I want to discuss with you today short circuit troubleshooting. All right, short circuit troubleshooting. And short circuit troubleshooting, we're going to apply a 10-step troubleshooting process for a fast and efficient fix to short circuit problems. Okay, so 10 steps I'm going to be using here today to so that we could go through a short circuit process. All right, 10 steps. And so along the way, we'll make sure that we follow best practices for human and equipment safety. So remember, we're the first thing that you have to do if you're going to troubleshoot a short circuit. You have your PPEs, and we were discussing it. I just show you your PPEs. You have a short circuit, you have your goggles, right? Your safety boots. If you're going on a live circuit, then therefore you have to ensure that you have your gloves and so forth, right? And you testing. And so there's 10 steps, but the first thing is that job site analysis report, job site safety analysis report, sorry, right? You need to conduct a job site safety analysis report. All right. So your job site safety analysis report is important here, right? And that's the first thing you supposed to be doing when you get to the site, right? So 10-step troubleshooting process, and let us go through the 10-step troubleshooting process. This lesson focuses on a particular electrical failure that needs to be found and fixed, rather than the typical guess and check method. We will apply the 10-step troubleshooting process, or which we would call for short the TSTP. The TSTP is a logical series of steps that can be adapted to nearly any troubleshooting problem and follow for an efficient and effective equipment fix. So so these 10 steps that we're going to go through is very important. Okay, so let us run through those 10 steps first in our introduction, right? So the 10 steps in our introduction today, the 10 steps troubleshooting process for short circuit, right? Or 10 steps troubleshooting process. Define the problem. That's the first thing. If you're writing, right, we're going to define the problem in this 10 steps troubleshooting process. Consult schematic. So if there's a schematic or you have a your website that you will pick up information, right? Right. So you ensure that you define the problem. That's number one. Number two is to consult your schematic, right? So get your schematic ready, right? Pertaining to the equipment, right? Model and serial number, right? And if you have spec and arrangement with some manufacturer would need that, right? List suspect components, right? So you're gonna list suspect components. That's number three. List subs suspect components, right? Four, isolate subcircuits. Four, isolate subcircuits. And if you see, does the problem remain, you can remove the whole subcircuit from the list. So, all right. So number four is to isolate subcircuits. Number five, right? Determine order of checking, right? So determine this number five, determine the order of check-in. Number six, physical observation. Physical observation. That's number six. Number seven would be test components. Test components. Right? Number eight is repair or replace failed components. Number nine, verify system. And number 10 would be new learning. All right, so these are the 10-step in troubleshooting process, right? And we want to just go through a scenario. Let us bring a problem into the front light, right? The problem. It's been a challenge to keep equipment running, and this morning or this afternoon, one of the wheel loaders seemed to have decided to call in sick. All right, so let's go through this process. When the operator started the loader, right, the lights flickered and died. The gauge backlights in the operator's console went out, along with along with all of the work lights on top of the cab. The entire circuit seems to be dead. All right. So let's go through the scenario back again. Right. The problem. We're going through a problem. It's been a challenge to keep equipment running, right? And this morning, one of the wheel loaders seems to have decided to call in sick. So this, call in sick. It's not starting, not working. When the operator started the loader, the lights flickered and died. The gauge backlights in the operator's console went out along with all of the work lights on the top of the cab. The entire circuit seems to be dead. Everything was fine when it was parked here last night or yesterday. What could have happened now? What is the problem now? Okay, so we decided to check this thing. Remember, you're doing a lockout and tag out on your machine. The first thing, lock out and tag out before you start any job, your job safety analysis. You lock out and tag out. If you're going to take off the battery, whatever, right? You got to take off your what? Your negative lead first. And so you disconnect your negative lead and you did your lockout and tag out. So remember that. So we're going through the system, a blown fuse, the sudden and complete failure of a whole circuit sounds like a blown fuse, right? So sure enough, when you check the fuse box, you find the evidence right away. No wonder this circuit is dead. The fuse has been fried, right? So the fuse has been fried. It would be seen enough to plug a new fuse in, but wait, leave the fuse out and don't energize that circuit. Leave the fuse out and don't energize that circuit. Something wrong here, right? Something wrong. Something, probably a short circuit, caused that fuse to blow. And until you find and fix that problem, you'll only continue to blow more fuses if you try to energize the circuit. It's time for some troubleshooting, right? So the first step, okay, the first step, electrical problem present in one of three ways. All right, define the problem. That's the first thing. Define the problem. That is step one. Let's define this problem. We found that the fuse is being blown, right? And other thing I want to mention here is that if it's one of the glass fuse, and you can observe the fuse condition to determine if it's a short circuit, right? So if your fuse, right, that you observe that fuse blown, right, if it's a short circuit, it would be dark. It would be like a spattered. It's not just gonna be the melting of the element. If there's an overcurrent, they will just be the element melt. When you look at a fuse, right? When you look at a cartridge fuse, you look at a glass fuse, whatever fuse you're looking at, and it's blown, you look at the element or the condition of the glass. If the glass is dark and black, right, that is a short circuit. If the element just melt, that is an overcurrent. It's not a short circuit. It's not a short circuit to ground. If it's a short circuit or short circuit to ground, short circuit between phases, your fuse will be black, darks. You're gonna be dark, right? You're gonna spattered, right? You're gonna see the darkness of the fuse. If it's an overcurrent, the element, right, just melts. They're gonna tell you that, hey, there's an overcurrent here. It's probably just there's some sort of loose slack connection somewhere that pulling more current, right? So you can determine as a troubleshooter, when you're troubleshooting, you take your fuse out. You're gonna look at the fuse condition. If the glass is dark and black, or black inside there, is a short circuit. If the element just melt, you can see the element just open, that is an overcurrent. It means that you get an excess current, right? Something is wrong. And so let's continue, right? And so we're going through this scenario. We found that this fuse blown, right? We found that the fuse blown. And so we're going through step one. We define the problem, right? Electrical problem present one of three ways. So you go, no, go. For example, the circuit does not operate at all. Both open and short circuits will cause no-go conditions. Both open or short circuit will cause a no-go condition. Erratic operation, example, the circuit works sometimes, but it but is not reliable. It works sometimes. All right. Incorrect value. The circuit works, but results are wonky, right? The lights may be dimmer, motors turn faster or slower than they should. Sensors display incorrect values. So, so these are scenarios. Our load problem is a textbook case of no go. Specifically, we suspect it's a no go caused by a short circuit. Step two, consult schematic, right? And gather documentation. Consult the schematic and gather documentation. If you have a schematic that is up to date, and verify for accuracy, because you might have a schematic that does not match up with the equipment. You have to ensure that is the model serial number specs, right, are correct, right, before you use the schematic. So ensure that your schematic that you're using for troubleshooting is accurate. Verify for accuracy, right? And when you verify for accuracy, we okay, congratulations, you have a correct schematic. You are miles ahead in troubleshooting this problem. An accurate and trustworthy schematic is the key to an electrical system. It can prove one, a list of all of the components in the system, often including exact part numbers, codes, and system-specific settings. Three, a diagram of relationships between system components, right? The exact location of test points, right? Ways to isolate sub-circuits for testing purposes. All right, so we're gonna go through a review of this thing, right? So we're gonna go through a review. We're gonna review in the short circuit. In step, we consult with our schematic and we gather documentation pertaining to this circuit, and we breaking it down. Okay? And so ways to isolate sub-circuits for testing purposes. Then we review the schematic, touch each, right? Call out to quickly review some circuit basics. All right, and so we'll go through that. So the first thing we would do, right, is that we look at our battery. Okay, we look at our battery. The electrical side of this machine is powered by a 24-volt DC battery bank. Look at the battery. We test the voltage at the battery, right? The voltage is good at the battery, right? It's going to the ground. You check continuity from your battery negative to ground to ensure that the negative is connected to the chassis, and that is continuous. Everything is good there. And then if you have a battery disconnect, you also, the circuit can be locked out using this disconnect, which is the battery disconnect. So let us go through the whole thing. So we get the battery, right? The electrical side of this machine is powered by a 24 volts. We know it's powered by a 24-volt battery, and it carries a battery disconnect. The circuit can be locked out, right, using this disconnect. So this machine carries a disconnect, and we have a fuse, a simple blade type automotive fuse, provides circuit protection. Then we have, when the ignition is off, key system on the machine do not run. All right, so we have this ignition, the ignition, which is the key switch, right? And then we will have a temperature switch, which we can say is 85 degrees or 185 degrees Celsius, which is 185 degrees Fahrenheit. So there's a temperature switch. Temperature switch, this normally open switch closes when the oil reaches 85 degrees Celsius or 185 degrees Fahrenheit. All right, so that switch closes, and then we have a high temperature light. So this high temp warning lamp, right, illuminates when the temperature switch closes, indicating the oil is overheated. Okay, so this is in the process. Then we have a hydraulic fan control valve, and we have the fan motor. So we're gonna go through this thing here. But the first thing what I want to mention is that your fuse is blown. You found the fuse blow, right? You found this fuse blown, and you decided, all right, you need to understand or determine what condition, what will cause the fuse to blow. And remember, we went through the step one, define the problem. Define the problem. You can look at the fuse and know exactly what is happening in this circuit. All right? You can look at the fuse and know exactly what is happening in the circuit. If the fuse, if you look at the fuse and the glass fuse and that globe is black, is dark. You see that like spatter, the element in there just spattered inside, and is all over in the globe, in the glass globe. And it's black, is a short circuit. And we're gonna go through a test to show you next week. If the element just open, if the element just melt, is an overcurrent. It's excess current is being pulled through the fuse. Something wrong. If that happens, maybe the fuse due to age, right? Or if there's a relay, whatever component is within the circuit, you just need to check to ensure that they're not pulling excessive current, like a loose connection or slack connection or so, right? Or contaminated, built up of oxidation, or system like that gonna have a tendency to pull excessive current, right? And so you need to check the circuit entirely and see exactly what is the resistance in this circuit, right? What is the resistance in the circuit? Why the element melt? Okay, open, because there's excess current. It's not a short circuit. So we know we have an excess current if the element doesn't melt. If the glass is black, we know we have a short circuit. All right. And so you're in the comfort zone and we're going through short circuit troubleshooting. Okay. And we were in a scenario and we were in step 2. We say consult schematic and gather documentation for this problem, right? And we gather documentation, review the schematic, right? Review the schematic. You see the components that are in the schematic. Okay. Scan existing documentation and records. Review the shop records. Has this loader or others like it been in for repairs recently? Look for evidence of a recurring problem or a maintenance induced problem, right? There is nothing suspicious in the shop records. The loader has been in for scheduled maintenance, no there but now there are no recent or there is no recent or suspect repairs that might provide a clue, right? So you're also going to look at the customer history. If it's not a shop, you look at customer history and see if this problem occurred before. All right. Step 3, list suspect components. Think of the ways each component could fail, right? Could that cause a no-go fault? In this step, try to list failures that could cause any or no go fault, regardless of how likely it may be. Right? So now you are analyzing the circuitry, and that is the only way you can do that, right? Fast and effectively is by you actually had to be trained or hands-on. You had training, and remember that hands-on is just the practical aspect of it, right? But you must have in-class training as well on a machine. You must have it in class training. Some people, right, they had hands-on training and that is all they know. They don't have the practical, the theoretical knowledge how this thing, right, really functioning and what is the reason. Because you have to know, you have to know the what and the why, right? Why this? What? What? Right? You have to know the what and the why. Why this need that? Why we need a transistor in this circuit? Why we need a fuse in this circuit? Okay, why we need a half amp fuse rather than a 1 amp fuse? Those are the things that are important to a technician. Knowledge, right? Those are important things. Because if you know the circuit, or if you knew the circuit, right, then therefore when you see an half amp fuse, you're not going to take a 10 amp fuse and put it in the circuit and say no, that's what we have, let it work. But because you can cause severe damage to components, right? And so therefore you have to understand the why this and what, right? So you have to understand the why they're putting this in the circuit, why this is a part of the circuit, right? Okay. You know that you will have a full practical understanding of the operation, and someone tell you how the circuit operates, But the components within the circuit, why are we using these components in the circuit? The purpose of those components, the purpose of the components in the circuit. All right. And so that's why I don't certified just practical or hands-on, but you have to have theoretical knowledge as well. It helps you also in your report writing, because if you understand the circuit, if you understand the operational procedures within the circuitry and the components as well, therefore you will give a good technical report, a report that will be understandable and to the customer and to your manager as well, right? So training in class is important, theoretical and practical. And so when you do your theory, right there you should able to do a practical aspect of what you are applying. Whatever you're being taught, you should apply practically. All right. And so you're in the comfort zone, and we're talking about short circuit troubleshooting. All right, we are already half an hour, and so therefore next week we'll have to continue on this topic, right? Short circuit troubleshooting. And remember that when the fuse is black or is dark in the globe, in that glass, right, it's a short circuit. And when the element just melt, is an overcurrent. Excess current is passing, right? Excessive current is passing through the circuit. And so if you like for example, you have a resistor, right? There are two resistors in parallel, right? That means that if there are two components, let us say there's two resistors or two components in parallel, right? Then therefore the voltage, right, across those components would be equal. The voltage, if it's a 240-volt system, or let us say if it's a 12-volt system, it's going to be 12 volt across the first one, it's going to be 12 volt across the second one. But the but here is that the current is different, right? The current is different in a parallel circuit, right? And so if you have, let us say, if you have a drop in resistance in one of those components, it will have a tendency to pull more current. If you have an increase in resistance in that component, it would pull less current. Okay? If you have an increase, it would pull less current. If you have a drop in resistance, it will pull more current. Okay? And so if we have two components in parallel, one is pulling 5 amp and one is pulling 10, and for some reason the resistance drop in the one that is pulling 10, they're gonna pull more. They're gonna pull now like 15 amps. And so if you have a 15 amps fuse in the circuit, the element gonna open, right? Because maybe it's just a slack connection. Okay. And so that would be a problem. And so you were in the comfort zone, and so you're listening to the tech corner. We're about to go, all right. And so I do hope that you enjoy the rest of the day, and we'll come back next week pertaining to tech corner and what we're gonna chat with. We're gonna continue short circuit troubleshooting. Okay, God bless.